We're going to do integration with long division here, and the nice thing about this is if it's a technique that works on a problem, it's just about kind of cleaning up a problem, simplifying it so it's easier to solve. So if you remember long division, you can use it to divide a higher order polynomial by a lower order polynomial. And all quotients with the first order denominators can be integrated. For higher orders, it depends on the result. So if you have something that's like 1 over x plus 2, if it's first order, so that this is x to the first, this can always be integrated. Whatever that is in the numerator, as long as it's not a variable, and whatever is in the denominator here, plus, minus, whatever. All those can always be integrated. Other ones depend on some results. So let's look at doing the long division as an example here. So we have the integral of 2x cubed plus 4x squared minus 5 over x plus 3 dx. So whenever you've got something, especially if the numerator has a higher order than the denominator, we're going to start by doing long division just to kind of clean things up a bit. If you're not super familiar with this, you'll need to go back and review it or check in with me to kind of get some personal help and support. So first, we're going to have x plus 3. How many times is x going to 2x cubed? Well, it's going to go in 2x squared times. So multiply that 2x cubed. 2x squared plus 3x is going to be plus 6x squared. And actually, I'm going to rewrite this here for reasons that will make sense in a minute. I'm going to write it as follows, plus 0x minus 5. That's just going to make it a little easier to do the math later. So now if I subtract this, the first terms cancel, and I'm left with negative 2x squared plus 0x minus 5. 2x squared goes in negative 2x times. So this will be negative 2x squared plus, not minus, 6x. So if I subtract these, I'm going to get 6x minus 5. And how many times does x go into 6x? It goes in 6 times, so plus 6x plus 18. Sorry that we're fritzing a little bit here. Subtract that. 5 minus 18 is negative 23 as our remainder. So that means I can rewrite this expression. The ultimate upshot is (2x squared minus 2x plus 6 minus 23 over x plus 3 dx. So I've just done long division to rewrite this first expression as this. Now you can start to see this a little bit easier to integrate. So we're going to get the integral of 2x squared is going to be 2/3 x cubed. The integral of negative 2x is going to be just x squared. The integral of 6 is going to be 6x. And now the integral for this one's a little bit tricky. We're going to have to use u substitution. U is equal to x plus 3. Du dx is equal to 1. So that means that dx is equal to du. So then I get what that ends up meaning is 23 divided by u, and I'm integrating that, so that will be 23 ln absolute value of u, which will be x plus 3, and then plus c. So yeah, like I had said earlier, anytime you've got a function like this where there's a constant and a first order plus another constant, it's always going to end up integrating pretty simply like this. So that's something you can kind of just memorize the rule for, but do it a few times by hand to make sure you don't get caught off. But that's our first example here. For our second example, we had x to the 6th plus 2x to the 4th plus 6x minus 9 divided by x cubed plus 3. So setting up our long division here, we're going to do x cubed plus 3, integrating into x to the 6th plus 0x to the 5th plus 2x to the 4th plus 0x to the 3rd plus 0x squared plus 6x minus 9. And we may not end up using all of these, but just having them written out gives us kind of the placeholders to work with. So first we're going to do x cubed, so that would give me x to the 6th plus 3x cubed. When I subtract that, I get 0, 0, 2x to the 4th minus 3x cubed plus 0, x squared plus 6x minus 9. Now we need a 2x. So 2x times x to the 2x times x cubed is 2x to the 4th. 2x times 3 is going to be minus, there's going to be 6x. So then when I subtract these, I'm going to get 0 minus 3x cubed. Those cancel, so minus 9. And so now we're looking at this x cubed section, and that should be minus 3. So minus 3x cubed. And minus 3 times that is minus 9. Subtracting those gives me 0 and 0, so that gives me a nice convenient 0. So there's no remainder in this one, which is nice. We don't have to worry about it. So that means when I actually evaluate this, I get this is equivalent to the integral of x cubed plus 2x minus 3. And this actually ends up being a lot easier to do than the previous one, because it's just 1/4 x to the 4th plus x squared minus 3x plus c. So this is when we're doing long division, we just want to see what we end up with, and if it ends up being easier to work with.